All right, Algebra 1, Lesson 4 for Distance Learning Assignment 4. This is Section 9.3 still. We're just extending it to a couple more learning targets. Those learning targets are still solving equations by working backwards, solving quadratic equations by working backwards using square roots. In this case, we're going to have some parentheses, so we've got stuff happening to the x that's getting squared. So that just changed what our answer looks like a little bit. Similar to what we did in chapter 1 with absolute value equations. And then we're going to look at some different types of quadratic equations. We're going to identify when we should use the method of solving by working backwards and when we would want to use a different method. So for example, like solving by graphing, or we'll learn later the quadratic formula, solving by completing the square, and we already know how to solve equations that are in factored form. So we'll get there. But the second learning target is when do we want to use this approach of solving by working backwards? So let's go ahead and get started. I've got problems 1 through 3 of the lesson of your assignment written here. Please take notes on these as we go through them, and then use these notes in this lesson that I'm doing right now to answer the questions problems 4 through 8. So let's go ahead and get started. Here we've got x minus 8 squared equals 100. So here we just think about how we solve an equation by working backwards. We identify like what's the last thing that's happening to x as far as order of operations goes. So we just read it. It's x minus 8 and then parentheses squared. So the minus 8's inside the parentheses. So that is happening to the x before it gets squared. So when we're working backwards, we got to undo the square part first. So what we're going to do is we're going to square root both sides to get rid of this squared piece. So step 1 here is actually going to be square rooting both sides. And we need to remember, whenever we're square rooting in an equation, like to solve, we got to throw in that little plus or minus. Say it could be either a positive or a negative square root of that number. So here, square rooting the square, that undoes the squaring, and we're left with whatever's inside the parentheses. So we said x minus 8 equals, and I'm just going to say plus or minus 10, because the square root of 100 is 10. So here I have x minus 8 equals plus or minus 10. Now I want just x, not x minus 8. So what I need to do is I need to undo what's happening to the x. So I need to add 8 to both sides. So I go plus 8, plus 8. So here basically I have x equals 8 plus or minus 10. And we gotta say, what does that mean? Well, it means x equals 8 plus 10. So x equals 18. Or x equals 8 minus 10. So x would equal negative 2. And those are our two answers there. All right, so the plus here, the minus there. So we still get two answers. In order to find those two answers, we got one more step in the middle. All right, let's jump to the next problem. Problem 2. So here, it's similar. It's just got a couple other things outside the parentheses as well. So what we're going to do, solve them by working backwards again. We're going to identify like what's the last thing happening or affecting the x on this side of the equation. Undo, 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 undo until we just have x equals. Let's go ahead and get started with that then. So I'm going to read it. It's 2 times x plus 3 squared minus 5 equals 27. That minus 5 is the last thing. So I'm going to undo by going plus 5 plus 5. That gives me 2 times x plus 3 squared equals 27 and 5 give me 32 when I add them together. So now once again I read through 2 times x plus 3 squared equals 32. Right, the first thing that happens to the x is the plus 3, then it's squared, then it's being, whatever the answer is gets multiplied by 2. So the multiply by 2 is what we're going to do the opposite of. So we're going to undo the multiply by 2 by dividing by 2. Not subtracting, but dividing, because that 2 next to parentheses is that implied multiplication. So we're dividing by 2, dividing by 2. Now I have the quantity, parenthesis, x plus 3 squared equals 16. And now I've got a problem similar to problem 1, where I have something squared equals a number. Even though there's a plus 3 inside this parentheses, there's a plus 3 happening to the x, right? It's inside that square, so we got to get rid of that squared part first before we can attack that plus 2. So I got to get rid of the square. The way we get rid of the square to that exponent of 2 is by taking the square root on both sides. And what do we need to remember when we're taking the square root on both sides? Plus or minus. So we go plus or minus, so positive or negative square root of 16 is what that x plus 3 is going to equal. So here I have x plus 3 equals plus or minus. Remember, 4 squared is 16, so the square root of 16 is 4, so plus or minus 4. We're going to, now, it's just x plus 3 equals this plus or minus 4. We go minus 3 to undo that plus 3. We get x equals negative 3 plus or minus 4. And here we want to finish it by writing 2 separate answers. So the way we do this is we split it. We say x equals negative 3 plus 4. So negative 3 plus 4 is going to give us a positive 1. Or x equals negative 3 minus 4. Because we have a negative 3 and a minus 4, that negative 3 is going to get more negative because we're taking 4 away from negative. So x equals negative 7. Those are our 2 solutions there. All right, one more problem, and then you get started on problems 4 through 8. So let's go ahead and look at this one. So problem 3, it's negative 2 times x plus 5 squared plus 1 equals negative 35. So same idea as with problem 2. We got to identify the last thing happening to the variable, to the unknown, and then work our way backwards by undoing. So the last thing happening is that plus 1, so we're going to go minus 1 on each side. Minus 1, minus 1. That gives us negative 2 times x plus 5 squared equals negative 36, because a negative 35 and a minus 1 is going to get it more negative. All right, now it's a negative 2 times that. Right, this is not a minus 2, it's a negative 2 times, because they're right next to the parentheses. So here, to get rid of that negative 2, we need to divide. So we're going to divide by a negative 2 on each side. Now what's happening, on the right-hand side, we had a negative 36. We're dividing it by a negative, so it's going to make it a positive 18. And that's a number that we can square root because it's positive. So here, we get x plus 5 squared equals 18. And now we're back to something that looks like problem 1. Right? Something happening to x but being squared equals positive number. If this was a negative number and we square rooted, then it would be no real solutions, but it's a positive, so we can square root. So to get rid of this squared, we're going to take the square root on each side, and every time we square root while solving, we got to throw in a little plus or minus there. So here I have x plus 5 equals positive or negative plus or minus square root of 18. And let's look at that square root of 18, right? Remember, right, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So the square root of the square root of 18 is going to be somewhere between 4 and 5, because 18 would be in between 16 and 25. So it's not like a perfect whole number. What it is, though, what we can do is we can simplify it. Remember, we take this 18, and this was from problem 9 and problem 18 from last week's assignment. And we say, hey, square root of 18, that's the same as the square root of what times the square root of what? And we're asking ourselves, which of these numbers divides into 18? Which of those? When we look at it, we say, hey, 9 divides into 18. 9 times 2 is 18. So we can say square root of 9 times square root of 2. Square root of 9 is 3. Right? Because 3 squared is 9, so then square root of 9 would be 3. So here I can say x plus 5 equals plus or minus 3 times the square root of 2. And for full credit, I want you simplifying these square roots. If they're not, well, I'm only simplifying all of them. If they turn out to be like a nice whole number, like 10 or 4, write that. If you get something like square root of 18, simplify it. Pull out that perfect square, like that 9 that divides into it. So you get a simplified answer here. Okay, so now we're here. X plus 5 equals plus or minus, positive or negative, 3 times the square root of 2. What we're going to do now is the exact same stuff that we did before. We're going to get rid of that plus 5, so we get x equals. So we're going to go minus 5, minus 5. So now I have x equals negative 5 plus or minus 3 square roots of 2. And now what it is, because here I've got a whole number, or sorry, an integer, just negative 5, and then I have actually what's called an irrational number. The square root of 2 is an irrational number. That decimal approximation just keeps going on forever. And I have 3 of those. So combining them just isn't going to be nice. I could do a decimal approximation, but then it's an approximation instead of an exact answer. So what we're going to do is we're just going to write it, keeping that square root in the answer. So the answer is going to be x equals negative 5 plus 3 square roots of 2, or x equals negative 5 minus 3 square roots of 2. And we just leave our answer in terms of these square roots. That way it's exact. That way, like, if you're working for NASA or something and you're trying to launch a rocket to Mars, right? Whoever's doing that actual calculation can determine how many decimal places they want to go to. This is the exact answer. Depending on the context of whatever you're doing, you can round appropriately. Okay, so problems 1, 2, and 3, that should set you up for problems 4, 5, 6, 7, and 8. Now, remember, if you get something like this, square root of 18, where it's not a perfect square, you can still simplify it and get an answer. It's when you get something like square root of a negative. So if I had, for example, square root of negative 18, that case is when we say no real solutions. So if it's square root of a negative, that's when we get no real solutions. All right, so go ahead and pause the video, try problems 4 through 8, and then resume the video, and I'll jump into the next learning target. So go ahead, work those problems while I erase this. All right. So next learning target is talking about when we should approach different problems with solving by working backwards. When is that an appropriate method for solving quadratic? So basically, I'm going to show you problems 9 and 10. We're going to talk a little bit about it. And then your task is going to be to do the rest of the problems by identifying, should you solve by working backwards or not? And if it is solved by working backwards, then go ahead and do the problem, like answer it. So you'll see that when I do this on problems 9 and 10 here. So problem 9, we have x squared plus 21 equals 85. Problem 10, here I have x squared plus 10x plus 21 equals 0. So what we want to do is we want to look at the problem and say, hey, can I solve it by working backwards? Let's look at problem 9 first. I look at problem 9, I say, hey, it's x squared plus 21 equals 85. What's happening to x? Well, it's getting squared, and I'm adding 21. All right, it's a pretty simple sort of steps. If I put a number in for x, I would square it, then add 21 to it, get 85. So here, it's a really simple set of steps I can take. I can solve by working backwards. So now, be like, yeah, solve by working backwards. To show that that's what I'm going to do, I'm going to do that. I'm going to solve by working backwards. So even though there's not the parentheses here, this is like an assignment 3 problem. So we're going to go minus 21, just undoing what's happening to x squared. So here I've got, let's use the pink marker that I started with. X squared equals 85 minus 21 is 64. To get rid of that squared, I'm going to square root it. So square root. Anytime we square root what we're solving, we need that plus or minus. So here I get x equals plus or minus square root of 64 is 8, because 8 times 8 is 64. And then we write it out as 2 answers, x equals 8, or x equals negative 8. And we're done. Wonderful. Cool. So let's look at problem 10. So problem 10 has an x squared plus a 10x plus a 21 equals 0. So here, if I was gonna work backwards and say what's happening to x, well, it's getting squared, but it's also adding 10 times itself, right? 10 times x. So here we've got an x squared and an x in the same problem. Now, if I was going to try to work backwards through this, I'd go minus 21, right? And then if I tried to work with the x squared, I'd go minus 10x and then square root, but then I'd have an x under the square root. And to undo that, I'd have to square it and I'd get back to this x squared. It's not going to work because of that x squared and the x. We can't just jump into solving by working backwards. So here, what we would do is we would solve using a different method. So solve using a different method. The one that you know right now is you could solve this by factoring. You could factor it, draw your little box out, say, hey, what times what gives you 21, that also adds 10. Write it out and solve appropriately. We'll work on that later this chapter. Right now, I just want you identifying when is it good to solve by working backwards, when is it, hey, let's use a different method. So that one is solved by using a different method. So those are our two examples. I'm going to summarize it a little bit, like when should we use which, or when should we solve by working backwards, when should we just say different method, and then you'll be set up to do the rest of the problems. So when to solve by working backwards. So solve by working backward. So examples that look like this. If I have something like ax squared plus c equals number, where basically just the x is getting squared, but there's no regular x. It's just an x squared. That's the only x you see, is just the x squared. Then you solve by working backwards. Or if you see problems like, well, 1 through 8. If you have something like a times x minus h squared plus k equals number. Right here, it's not just an x squared, it's an x minus h squared, but the only thing happening to that x after you subtract the h, or add, or whatever this is inside of the parentheses, is that square. There's not another x hanging out somewhere in the problem. All right, so solving by working backwards is basically if it's in vertex form, or if it's in this standard form, but there's no regular x in there. Right? There's like 0x, 0 regular x's, just the x squared. So now I'm going to give you some examples of when to solve, or sorry, when to just say different method. So, different method. So example problems for when we would just say, hey, let's solve using a different method could be, well, if I have ax squared plus bx plus c equals a number. So if it's in standard form, like you graphed in assignment 2, right, where we've got an x squared and an x, here you would use a different method, because working backwards, right, square rooting this x would make that a square root of x, which then we couldn't solve using that method. So that's a way we would not solve by working backwards. If it's in factored form, like x minus a times x minus b equals 0, right? Or equals some other number, doesn't have to be 0. Here, like, there's multiplication and subtraction of each x. We just wouldn't solve by working backwards. If it's equal to 0, right, we would just go like, hey, x minus a equals 0, x minus b equals 0. If it was equal to a different number, I'd have to multiply it out, subtract over, and solve it using a different method anyway. So basically, we want to solve it by working backwards if we just have the x squared. So just an x squared, or just like an x plus or minus something in parentheses squared, and no other regular x's in the problem. If there's an x squared and an x, use a different method. We'll learn those, quadratic formula, factoring, that sort of thing. We already know factoring. If it's in factored form, like this, we can solve by using zero product property if it's equal to 0. If it's not equal to 0, you would solve by, well, using a different method. We'll attack those problems later. Okay, so now you're set up to finish the rest of the assignment. Hopefully it's not too bad this week. Most of y'all that turned it in this week did really well, so let's keep that progress going. Cool. I think that's it. yeah, quick and easy today. All right, send me an email if you have questions, and enjoy. Have a wonderful week. You rock.